The sensation of floating above one's body, the tunnel of light, and profound peace are hallmarks of near-death experiences. These events, reported by millions, are often cited as evidence for consciousness surviving bodily death. However, the scientific consensus points toward complex, measurable neurological processes triggered by extreme physiological stress. When the brain is starved of oxygen or blood flow, a cascade of neurochemical events begins. This video dissects the two leading physiological candidates for NDE generation, cerebral hypoxia and the potential endogenous release of dimethyltryptamine, or DMT. Understanding these mechanisms reframes NDEs from spiritual mysteries into predictable, albeit intense, biological phenomena. NDEs are defined by a consistent set of subjective experiences occurring during periods of imminent death or severe trauma. Common features include autoscopy, the feeling of observing one's body from an elevated perspective, and the rapid, non-linear review of one's entire life history. The perception of entering a dark tunnel, followed by an intensely bright, loving light, is reported globally, irrespective of cultural or religious background. These experiences are often accompanied by a complete absence of fear and an overwhelming sense of unity or transcendence. Crucially, these subjective reports correlate strongly with periods of cerebral ischemia, where blood flow to the brain drops below critical levels. Cerebral hypoxia, the lack of sufficient oxygen supply to the brain, is a powerful trigger for NDE-like symptoms. As oxygen levels drop, the visual cortex, which requires high metabolic activity, begins to fail. Peripheral vision is lost first, creating the classic tunnel effect as the remaining central vision struggles to function. This progressive failure is not random, it is a predictable consequence of neuronal energy depletion. Furthermore, the release of inhibitory neurotransmitters like GABA decreases, leading to disinhibition and heightened electrical activity in surviving neurons, which can generate intense, meaningful visual and auditory hallucinations. When blood flow ceases entirely, a condition known as cerebral ischemia occurs, often leading to cortical spreading depression, or CSD. CSD is a massive wave of depolarization that sweeps across the cerebral cortex, effectively shutting down neuronal function. This electrical storm releases a flood of excitatory neurotransmitters, including glutamate, which can cause a final intense burst of consciousness just before complete blackout. Studies monitoring brain activity during cardiac arrest have shown a massive surge of high-frequency gamma waves immediately following the cessation of circulation, suggesting a hyperconscious state preceding clinical death. This surge correlates precisely with the timing of reported NDEs.
Dimethyltryptamine, DMT, is a potent psychedelic compound naturally occurring in many plants and potentially synthesized endogenously in the mammalian brain, particularly in the pineal gland. The hypothesis suggests that extreme stress, such as trauma or cardiac arrest, triggers a massive release of DMT into the bloodstream. DMT is structurally similar to serotonin and acts primarily on the 5-HT2A receptor, producing profound, short-lived hallucinatory states that strikingly mimic NDE phenomenology, including encounters with entities, feelings of transcendence, and rapid shifts in perception. Animal studies have confirmed the release of DMT in the rodent brain during induced cardiac arrest. The pharmacological action of DMT provides a strong parallel to NDE reports. Activation of the 5-HT2A receptor disrupts the default mode network, the brain system responsible for maintaining the sense of self and linear time perception. This disruption explains the reported ego dissolution and the feeling of timelessness common in NDEs. While DMT is known to be synthesized in the brain, definitive proof of a massive terminal release sufficient to induce NDEs in humans remains elusive due to the difficulty of measuring neurochemistry during acute death events. Current research relies heavily on animal models and post-mortem analysis to infer human physiological responses. While the DMT hypothesis is compelling, it faces significant challenges. Many NDEs occur over extended periods, sometimes hours, while the DMT's effects are typically short-lived, lasting only minutes. Furthermore, other endogenous compounds are known to be released during trauma. Endorphins and enkephalins, natural opioids, are released in massive quantities, explaining the profound sense of peace and lack of pain reported by NDE experiencers. Additionally, NMDA receptor antagonists, such as ketamine, produce dissociative states, including out-of-body experiences, which closely mirror autoscopy reported in NDEs, suggesting multiple pathways contribute to the overall experience. The ability to pharmacologically induce NDE-like states strengthens the physiological explanation. Patients administered high doses of ketamine often report classic NDE features, including tunnel vision, meeting spiritual beings, and profound existential insights, all while the brain remains oxygenated. This demonstrates that the subjective experience of leaving the body and entering another realm is achievable purely through manipulation of neuroreceptor systems. Dissociation, the detachment from physical reality, is a key mechanism, often linked to the brain's attempt to cope with overwhelming sensory input or trauma by shifting processing away from the body. This protective mechanism generates the feeling of peaceful detachment. Within the framework of secular humanism, near-death experiences are understood as complex, predictable neurological events arising from extreme physiological stress, not supernatural incursions. The consistency of NDE reports across cultures reflects the universal architecture of the human brain and its response to systemic failure. These experiences offer profound insights into the nature of consciousness, demonstrating that our deepest sense of self and reality is fundamentally dependent on specific neurochemical balances and electrical activity. NDEs are powerful subjective experiences, but they are ultimately products of the biological machine, providing a window into the brain's final, desperate attempt to process reality.